Hello, and welcome to G Fun Facts Online. How many times today have you checked a map on your phone? Or maybe you've paid for something with a tap, or even just enjoyed the fact that the lights are on. Behind almost all of it is an invisible choreographer, a constellation of satellites orbiting thousands of kilometers above us. The Global Positioning System, or GPS. It's the silent rhythm our modern world dances to. But what if that rhythm stopped? What if this marvel of engineering has a hidden weakness, an Achilles heel that could send our tech-dependent society into a tailspin? Today, we're unmasking the science behind satellite navigation's biggest vulnerabilities, the most immediate threats errant from space, but right here on the ground. Let's talk about the treacherous twins, jamming and spoofing. Imagine trying to whisper a secret to a friend while someone stands next to you blaring an air horn. That's GPS jamming. A simple, cheap device can broadcast a powerful radio signal that just drowns out the weak GPS signals that have traveled all the way from space. A single truck driver trying to avoid his boss tracker once plugged one of these into his cigarette lighter and accidentally disrupted flight tracking at Newark International Airport. That's the brute force attack. Spoofing, on the other hand, is more like a master of disguise. It's a sophisticated attack where a fake, counterfeit GPS signal is sent to your device. This fake signal is stronger and more convincing than the real one, tricking your phone, your car, or even a massive cargo ship into thinking it's somewhere else entirely. In the Black Sea, multiple ships suddenly saw their navigation systems place them miles inland, on dry land. It's a digital ghost, leading technology astray. But it's not just malicious humans we have to worry about. A far more powerful force can throw a wrench in the works: the sun. Our star isn't always the calm ball of light we see. Sometimes it sneezes. These solar sneezes, known as solar flares or coronal mass ejections, blast massive amounts of energy and charged particles into space. When this space weather hits Earth, it supercharges a layer of our atmosphere called the ionosphere. This can distort, delay, or even block the GPS signals trying to pass through, leading to huge errors in positioning. A powerful solar storm could knock out power grids, damage satellites, and disrupt communications globally. Back in 1989, a storm caused a 9-hour blackout across Quebec. That's the kind of unpredictable power we're up against. So why is this so critical? Because a GPS failure doesn't just mean your map app stops working. It triggers a domino effect. Our critical infrastructure is a tightly woven web, and GPS is the thread holding much of it together. In transportation, planes rely on it for landing. In telecommunications, 5G networks need its precise timing to sync data. Our power grids use it to prevent blackouts. Even the global financial system uses GPS to timestamp transactions. A loss of GPS could halt markets, destabilize the power grid, and cripple emergency services trying to locate those in need. It's a single point of failure with the potential for a cascading, society-wide crisis. The good news is, we're not just sitting around waiting for the worst to happen. There's a global effort to build a more resilient future for navigation. Think of it as having backups for your backup. Modern GPS receivers can now listen to multiple satellite systems at once, like Europe's Galileo or China's Beidou. If one system goes down, the receiver just switches to another. We're also pairing GPS with Inertial Navigation Systems, or INS. An INS is a self-contained device that uses gyroscopes and accelerometers to track movement without any external signal. Think of it as a smart compass that knows where it's going, even in a tunnel where GPS can't reach. And for the future, we're looking at a quantum leap. Scientists are developing quantum sensors, incredibly precise atomic clocks and gravimeters that could provide navigation completely independent of satellites. It's like giving a ship its own celestial map, written in the language of atoms. Our reliance on the invisible signals from space is one of the great, unsung stories of the modern age. But its fragility is a vulnerability we can no longer ignore. From fighting off digital ghosts like spoofers, to bracing for solar sneezes and building quantum compasses, the quest to secure our navigational future is one of the most important challenges of our time. It's about ensuring that the rhythm our world dances to never misses a beat. Thanks for tuning in to G Fun Facts Online.